Introduction for host a web application with Azure App Service. Now imagine you are building a website for a new business, or you are running an existing web app on an aging on-premises server. So setting up a new server can be challenging. You need appropriate hardware, likely a server-level operating system, and web hosting stack. Once it is running, you need to maintain the server. And what happens if your website traffic increases? You might need to invest in additional hardware. However, hosting your web app using Azure App Services makes deploy and managing a web app much easier and faster when compared to managing a physical server. So, in this section, we will implement and deploy a web app to app service. So, the learning objectives will be like this. In this section, you will use the Azure portal to create the Azure App Service web app, use developer tool to create the code for a starter web application, deploy your code to app service. So the prerequisites, not much actually. Ability to navigate the Azure portal, which is very easy. Ability to use command line interface, no big deal. Alright, I will see you in the next lecture. Create a web app in the Azure portal. Now this is a theory lecture. In the next lecture, we will start with the exercise. Now why to use the Azure portal? Now the first step in hosting your web app is to create a web app in Azure App Service app inside your Azure subscription. There are several ways you can create a web app. You can use the Azure portal, the command line CLI, a script, or an integrated development environment IDE like Visual Studio. The information in this unit, we will discuss how to use the Azure portal to create a web app, and you will use the information to create a web app in the next exercise, alright? Now we will demonstrate using Azure portal because it is a graphical experience which makes it a great learning tool. And the portal helps you discover available features, add additional resources, and customize existing resources. So what is Azure App Service? Let's have a quick look here. Azure App Service is a fully managed web application hosting platform. This is a platform as a service PaaS offered by Azure, which allows you to focus on designing and building your app while Azure takes care of the infrastructure to run and scale your applications. Now, one of the feature and very important feature for the app service, which is the deployment slots. Don't worry, we will talk about it in details. However, keep that in your mind for now as a theory part. So using Azure portal, you can easily add deployment slots to an app service web app. For instance, you can create staging deployment slot where you can push your code to test on Azure. Once you are happy with your code, you can easily swap the staging deployment slot with the production slot. You will do all this with a few simple mouse clicks in the Azure portal. Of course, you can do this again in Azure CLI, scripts, any other tools, templates, etc., etc. Now, another feature, which is the CI/CD, Continuous Integration Deployment Support. Now, the Azure portal provides out-of-the-box continuous integration and deployment with Azure DevOps, GitHub, Bitbucket, FTP, or local Git as well repository in your development machine. So you connect your web app with any of the above sources, and App Service will do the rest for you by automatically syncing your code and any feature changes on the code into the web app. So you can see that here, Azure App Service here can make the process very quick and fast. So you don't need to create a pipeline from the scratch. Actually, it is a feature within. Okay, you can see that it is a built-in feature. Furthermore, with Azure DevOps, you can define your own build and release process that compiles your source code, runs the test, builds a release, and finally deploys the release into your web app every time you commit the code. All that happens implicitly without any need for you to intervene. You can see that. Again, no worries. We will talk about that in details in the next lecture. Integrated Visual Studio publishing and FTP publishing. This is very important thing. So in addition to being able to set up continuous integration deployment for your web app, you can always benefit from the tight integration with Visual Studio to publish your web app to Azure via web deploy technology. App Service also supports FTP-based publishing for more traditional workflows. Now, there is a built-in autoscale support, automatic scale-out based on real-world load. The ability to scale up, down, or scale out in is baked into the web app. Depending on the web app's usage, you can scale your app up or down by decreasing the resources of the underlying machines that is hosting your web app. So resources can be number, of course, of the amount of RAM available, which means increasing up, scaling up. You can see that. Increase the amount of CPU or the RAM, the size of the server or worker or instances that hosting your app, or you can scale out. You can see that, which is on the other hand, is the ability to increase the number of the instances that are running your web app. By the way, you can see that the instance or worker or machine, they are the same concept here, okay? Now, creating a web app. So when you are ready to run a web app on Azure, you can visit Azure portal and then create a web app server. No worries. Now again, this is just a theory, but here we are talking about. In the next lecture, we will talk all about these. Okay, so we will create a web app, and we can define the resources we want. We can choose the web-based application that the stack runtime, either ASP.NET Core, Node.js, Java, Python, etc., etc. Okay. Now again, this is just a theory part. We will talk about it in details. However, these are the fields we will see: the subscription, which is the valid and active Azure subscription; resource group, a valid resource group; the app name, and here you can see we can publish. You can deploy your code as a code and ready as a Docker image. You can see that. There is the runtime stack. We talked about it previously: Node.js, Python, Java, and .NET, etc., etc. And operating system, you choose it as Windows or Linux for now, and the region where you want your website to be hosted, in which region, and the app service plan. Now again, all of that will be handled and discussed in details in the next lecture, in the hands-on. For now, just follow me. So if you are deploying your app as a code, many of the available runtime stacks are limited to one operating system or other. So after choosing a runtime stack, the toggle will indicate whether or not you have a choice of operating system. And if your target runtime stack is available on both operating systems, select the one that you use to develop and test your application. Now, if your application is packaged as a Docker image, choose the operating system on which your image is designed to run. Selecting Windows activates the monitoring tab, where you can enable application insights, and enabling this feature configures your app to automatically send detailed performance telemetry to the application insights monitoring service without requiring any changes to your code. Again, this will be discussed in details in the next lecture. No worries. Just for now, keep in your mind, we have a feature called Application Insight. This is from Azure, a service provided from Azure, and this can actually monitor your application, and it is very detailed performance telemetry, and it is actually very useful. All right, we will talk about it later on. Also, you can use Application Insight from a Linux hosted app as well, but this turnkey no code option is only available on Windows. So you can see that it is on Windows and Linux, the Application Insight. However, most of the use cases actually for Windows, as in Linux, it doesn't have the no code option. Okay, we will talk about it, no worries. For now, follow me. Now we have the app service plans. App service plan actually is a set of virtual server resources that run app service apps. Okay, this is actually the plan size, sometimes referred to as SKU or pricing tier, determines the performance characteristics of the virtual servers that run the apps assigned to the plan, as well as the app service features to which those apps have access. Every app service web app you create must be assigned to a single app service plan that runs it. Okay? A single app service plan can host multiple app service web apps. In most cases, the number of apps you run on a single plan will be limited by the performance characteristics of the apps and the resource limitation of the plan. App service plans are the unit of billing for app service. So, the size of each app service plan in your subscription, in addition to the bandwidth resources the apps deployed to those plans use. Okay, so determine the price that you need to pay. Okay, so after all, in a conclusion, the app service plan actually is a set of virtual servers that sets the pricing and the characteristic of the resources you are hosting your app on. Okay, it is, let's say it in a simple word, actually it is the size of the hardware. Okay, I need 1 gig RAM, I will need 2 core CPU, I need 4 gig RAM, I need 4 core CPU, etc, etc. And what is the type of the CPU, the type of the RAM, how much faster the SSD, etc, etc. Okay, all of that depends on the app service plan. This is the app service plan. All right, actually, and at the end of the day, it is just the size of the hardware you are using to host your app. By the way, it is managed completely from Azure, Microsoft, so no need to maintenance or dispatching, all of that, because after all, it is a PaaS, platform as service. So the number of web apps deployed to your app service plans has no effect on your bill. You can use any of the available Azure management tools to create an app service plan. When you create a web app via the Azure portal, the wizard will help you to create a new plan at the same time if you don't already have one. Now, in the next lecture, as we talked about, we will start handling and creating our first web app service here on Azure, and we will talk about a hands-on details more than a theory. All right? Thanks for watching. Okay, now the first thing, let's go to the Azure portal. Type in your browser portal.azure.com. Then from here, you can find it here, app services, the app service here, the Azure services, or you can type it here, app services. You can see you find it here. Click on it. And from here, you can see that we have the create button. Click on the create button. Now here, you will notice all of the information. Now let's start with the basic tab. Now first, we will choose the subscription. You must have already a subscription, okay? And then you need to have a resource group. Now, a resource group is a collection of resources that share same life cycle, permission, and policies. You can create a new one, or you can choose anyone from you already, if you already created a new one. Now, let's start with the instance details. For now, here you can put the name of the app you want. So let's put host or web app test or whatever, okay? And here you can see that currently the name is not available. So I want to put 99, web app -test 99, and you can see now it is available. By the way, the publish code here type is either a code, either a Docker container, either a static web app, okay? You can choose one of those three, all right? Now, for our time here, as a first time, we will choose a code here first. And from here, the runtime stack, here we can choose whatever runtime stack we want. .NET, Go language, Java, PHP, Python, and Ruby, you can see. For our here, we can use a Python. So let's use Python 3.9 for now, or anything, okay? And the operating system here, you can notice it is Linux only. I cannot choose Windows because for Python, Windows is not available. However, for the PHP and Java, the Windows is available, and other languages. Now choose the region or let it as is, which is East US, or whatever. If you want another region, you can see that there is France, Japan, here you can see Korea, Poland, Qatar, and here you can see that there is from India, UK, etc, etc, and India here you can see, and Europe. All right, for our, I will choose the default one, okay? Now the pricing plan here, as we talked about previously, which is the app service plan, which is the SKU or the pricing tier, and the size of the hardware. In our here, we will choose, you can see that I can select from here if I already have one, or let's create a new one, which is what we want to do. And let's name it app plan test or whatever you want, and click OK. And here you can see that we are able to choose from those, okay? So you can see that these are the popular plans. The F1, which is the free, and you can see that it is $0 per month, nothing will be paid. We have the basic, the B1, which is $12 per month. We have the premium V3, which is, as you can see, 113 approximately USD per month, etc, etc. You can see that if you scroll down until you reach the isolated, which is the most used with the enterprise, which is, as you can see, but however the price is going up like dramatically. You can see that here up to 1,127 USD per month. However, it has like 32 gigabytes of memory as well as 4 CPU core, or sorry, 8 virtual CPU core, which is a really high and huge server here we are talking about. Okay, for our case here, we want to choose the F1, which is the, you can see the F1, which is the free. All right. And by the way, you can click on the explore plans here. Here it will show you more detailed about it. Here you can see that we can choose the free, and all the detailed information is here. You can see that the SUV virtual CPU, the virtual CPU, the memory, how much memory with gigabyte, how much storage with gigabyte, the scale. You can see that here is not available, the scale. The cost per hour is free and the cost per month is free. You can see that there it is nothing. All right, until you reach down, you can see that isolated. You can see that the price go dramatically. All right. Now there is also the feature view if you prefer, and here you can see that each one has its own, like here it will show you that this F1, B1, B2, B3, these are for live or test for less demanding workloads. Okay. However, what we now choose what depends on what you prefer. But for now, of course, you should choose F1 because you need it to be a free of cost. All right, just for the sake of learning new things. All right, select it now. As you can see, I have selected F1 free. Here the zone redundancy, because it is a free, it is disabled. I cannot have this. However, this is actually a good feature, which is to make sure that your servers are distributed redundantly or across all the zones in the region. Okay. Okay, for now, just we want it as a disabled. We will talk about this in detail later on. Just follow me for now. Now, next, let's have with the deployment. Okay, the feature here for now, we will choose, okay, leave it as disabled in this lecture. All right, so let's have it disabled, and we don't need any deployment for now for the code. Let's click next on the networking, and here make sure the enable public access is enabled. Okay, as you can see on. All right, and you can see that there is a feature called network injection, but it is only available in basic, standard, premium v2, v3 dedicated app service plans only. Okay, so for the free one it is not available. Okay, and actually we will talk about this later on. However, for now let's move on. Okay, the same thing for the monitoring. You can see, as we mentioned before, that we can use the application inside. This is a service provided from Azure for application performance management, and it is for developers and DevOps professionals, so you can automatically monitor your application. However, for now, let's leave it as no, we don't need it. Let's click on next. Here you can add the tags you prefer. Depends on either if you want it on the app service plan or the web app itself, because we are creating a web app inside the app service plan. All right, for now we don't need to have anything. Let's click on the create and review, and here you can see that this is the web app, this is the review, free school, and the details are like these. We are runtime as Python 3.9. Here are the app service plan information. The monitoring is not enabled. The deployment is not enabled for now. The continuous deployment, as we talked about it previously. Now, after everything, if you review everything and all is good, you can just click on the create button. Now, let's wait a little bit until it is done. Here you can see that the deployment is in progress, and it will show you everything you want. Now, after it is done, you can see the deployment is complete. You can click on the go to resource. This will point you to the right web app you have just created. And here you can notice the web app test 99 as we created and named it. Or here are the resource group. Here is the status. Here's the location where it is, the subscription ID, domain, and here the app service plan, and you can see. Now, if you click on browse here, all right. By the way, you can see that currently the app service plan is F1 with 0 worker running. So I need let me refresh here. And now you can notice it is 1, which means that currently it is 1, and we have 1 worker running of the type F1. So let me close and let me browse again. Now, You can see because it is free, it is really like slowly somehow, because after all it is like the RAM is little bit and the core CPU are really little. Okay, so here you can see your app is running and waiting for your content. All right, now you can see that now it is up and running. However, these are the default web page. Okay, and these are actually because we don't have any deployment content yet. All right, no worries, we will talk about these later on in this course. However, for now we have just created our test app and with the school, and we have learned the different arguments and parameters we have. All right, okay, all right, thanks for watching. Okay, prepare the web application code. Now bootstrap a web application. So now that you have created the resource from the previous lecture for deploying your web application, you have to prepare the code you want to deploy. There are many ways to bootstrap a new web application, so what we will learn here might be different to what you are used to. So the goal is to quickly provide you a starting point to complete a full cycle to the deployment. All right, so now we will use, and we will assume we are using a Python Flask application. All right, so to create a new web application starter using a few lines of code, you can use Flask, which is commonly used web application framework for Python. You can install Flask using the following command: pip install Flask. After Flask is available in your environment, you can create minimal web application using this code. So from Flask, import Flask, and the F is capital here, you can notice. App equal Flask F is capital and with underscore underscore name underscore underscore. Okay, and then at app.route slash, which means the default one, define the function hello and return hello world with \n. Okay, so this example code create a server that answers every request with hello world message. So adding your code to the source control. After your application code is ready, the next step is usually to put the code into source control repository such as Git. If you have a Git installed in your machine, running these commands in your source code folder will initialize the repository. Git init, git add dot, which means add everything, and git commit with -m, which means message initial commit, and this will be committed on the local Git repository that you have initialized. So these commands allow you to initialize a local Git repository and create a first commit with your code. You immediately gain the benefit of the ability to keep a history of your changes with commits. Later on, you will also be able to synchronize your local repository with remote repository, for example, hosted on GitHub. So this allows you to set up a continuous integration, continuous deployment CI/CD, while we recommend using a source control repository for production application. So it is not a requirement to be able to deploy an application to Azure App Service. All right, now we will talk about this as a hands-on in the next lecture, how to do all of that. Thanks for watching. You can type download Python 3 on Windows, and you can see that it will provide us with a downloadable MSI executable, and it will be downloaded and installed correctly. Like the following, you can see that download Python 3 Windows, and here click on the first one. And from here, you can just click on download Python 3.11. Now, this is the same thing if you want to have older versions. So 3.7, 3.8, 3.9, 10, etc., etc. Okay? And if you here, you can see that you can install it as Windows installer 64-bit like this. Okay? Okay. Because you are a Windows user, you can just right-click and open the terminal, the PowerShell, as you can see. Then if you type Python 3 here, you can see that now Python 3 is here, and you can exit from it. All right. Now the command will be like the following: Python 3 -m vinf, and the v is small, vinf, and press enter. Okay, now let's wait a little bit, and you can see the folder vinf has been created. Now what we want to do is actually enabling the vinf, the virtual environment. Okay, now because we are in PowerShell here, you can see that if we go to the vinf directory, like this, and go to the script, okay, let me clear the screen. Here you can see that the activate is here, And we have another activate like for the PowerShell, which is what we want, okay? So let me just type this, PowerShell, or another way, which is using the bat. Okay, by the way, now why this didn't happen or didn't work? Because by default, the PowerShell scripts are disabled. We can enable them, but for now, we can just use this one, the bat. Now, after it has been enabled, we can use pip install Flask. Okay, now after it has been installed, now let's create a new text file or new Python file. Let's name it app.py. We can use the following command, app.py, like this. This will open Visual Studio, okay? Now, let's use this code. You can see it from Flask, import Flask, as we discussed from the previous lecture. App, Flask name, app route, define hello, and here you can return the value HTML body, h1 hello test app, h1 body, let's close the HTML, okay? Let's use this one. Okay, now to run this code and test it out, okay, let's return back to the PowerShell, and from here, we can, first, let's put set the Flask app name to equal app.py, okay, which is now set variable here, I want to use. Now Flask run. Now if I go to the local host with the port 5000, you can see that hello test app has been applied. You can see the same thing, we got a request here from local host, okay? As you can see, now we are running on this. By the way, this is just for development server. Don't use it on production. Because you can see that if we return back to the code here, you can see that the hello function here return an HTML rendered page. So it will be like a page with hello test with h1 tag, okay? Now, thanks for watching. In the next lecture, we will learn how to deploy this code to the app so it can be run and working correctly on our app service on Azure. Thanks for watching. Deploy code to app service. Automated deployment. So automated deployment or continuous integration is a process used to push out the new feature and bug fixes in a fast and repetitive pattern with minimal impact on end users. Azure supports automated deployment directly from several sources. The following options are available. The Azure DevOps, you can push your code to Azure DevOps, build your code in the cloud, run the tests, generate a release from the code, and finally push your code to Azure Web App. GitHub. Azure supports automated deployment directly from GitHub. When you connect your GitHub repository to Azure for automated deployment, any changes you push to your production branch on GitHub will be automatically deployed for you. We have a Bitbucket. Bitbucket, with its similarities to GitHub, you can configure an automated deployment with Bitbucket. OneDrive. OneDrive is a Microsoft cloud-based storage. You must have a Microsoft account linked to a OneDrive account to deploy to Azure. We have Dropbox as well. Azure supports deployments from Dropbox, which is a popular cloud-based storage system that is similar to OneDrive. We have a manual deployment as well. There are a few options that you can use manually to push your code to Azure, which is the Git. App Service Web App feature a Git URL that you can add as a remote repository. Pushing to remote repository will deploy your code. We have AZ Web App Up. Web App Up is a feature of AZ command line interface that packages your app and deploys it, unlike other deployment methods. AZ Web App Up can create a new app service web app for you if you haven't already created one. We have the zip deploy. You can use AZ Web App deployment source config zip to send a zip of your application files to app service. You can also access zip deploy via basic HTTP utilities such as curl. We have the war deploy. War deploy is an app service deployment mechanism designed for deploying Java applications using WAR packages. You can access WAR deploy using the Kudu HTTP API located at this URL, which is your app name .scm.azurewebsites.net/API/WAR deploy. Don't worry, we will talk about that in detail later on. For now, just keep that in your mind. If that fails, you can try this another, which is, you can see that the app name .scm.azure website API WAR deploy. You can see that either HTTP, the difference is HTTP, or HTTPS here. You can see we can use the Visual Studio. Now Visual Studio features an app service deployment wizard that can walk you through the deployment process. Also there is FTPS. So FTP or FTPS is a traditional way of pushing your code to many hosting environments, including app service. So these are actually the manual deployment. Now again, it depends on what your preference. However, it is of course better to use automated way because it is much faster and it will provide quickly. Alright, thanks for watching. Okay, now as we learned from the previous lecture and we saw, now we want to deploy this code, which is as we previously saw on the app service in Azure. So to do so, now there is actually continuous deployment as we mentioned before, which is a very recommended. However, we can use the manual, which is the AZ web app. So here, open a new terminal and let's go to where this app, and here as you can see here is the app we want. So we will put this command, AZ web app name. This is the app name, and as we saw previously, the app name will be like this. Here is it, and the resource group, you want to put the resource group here, and you can get it from here, resource group, and the plan, the app service plan, and you can get it from here as well. You can see here it is, the app service plan. Of course, you need to remove this. You just need to put the name and the SKU here. So let me change this to put it the SKU, which is the pricing plan, and the location here. We want to put the location. So the location will be as we saw previously. It is East US, okay, like this. However, this should be a one word like this, and small letter or capital letter the same, okay. And now press enter. By the way, you can see that because my session has been expired, or I'm not, so I need to use AZ login. Press enter and login. Okay, now you can see that after login, it will be work. Let's press enter and see what will happen right now. Now we saw from the previous here that it didn't detect the runtime. No worries. We can use this argument, which is -- run time, okay? And then provide in double quotation, which is Python, then with colon 3.9, and press enter. You can see that the web app test99 already exists, and the command will deploy contents to the existing app. Now let's wait a little bit. So here you can see that here is the source path, and it has been deployed successfully. So now if I go to the app here, and if I click on browse, now here you can see that it has been deployed successfully. Now remember what was showing before? It was showing the default page, okay? But now you can see that it is showing hello test app, the same one as we saw previously when we run it locally, okay? Okay, thanks for watching.